Okay, our next couple of lessons deal with what we call parent functions and transformations. Basically, a transformation is exactly what it sounds. You take an original graph and you translate it, reflect it, those different transformations that you learned in geometry. So we're going to kind of look at it at an Algebra 2 standpoint and how doing certain things to the equation transforms the graph. So all you're going to do here is just kind of get started looking at what we call parent functions. So functions that belong to the same, what we call family, share key characteristics. And a lot of times those key characteristics are the shape of the graph. And we'll talk about that in a second. What we call the parent function is the most basic function in the family. And this is with no transformations. So the parent function is the function in the family with no transformations. So all your goal is here is just to look at the different types of function families and parent functions that we have. I'm going to go through all of them, but there are 4 that we are going to focus on, and I'll tell you which 4 those are so you can kind of focus your attention and your studying on those in particular. So the first type of function that we have is what we call a constant function. And you can see in the graph that this is a horizontal line. And if you look at the equation, it is just y equals c. And that c is some constant, meaning some number. So for example, y equals 3 is a constant function. Now, we are also going to talk quickly about domain and range. This is something you would have talked about a little bit in Algebra 1. Basically, domain is all of the possible x values, and range are all of the possible y values. We're kind of giving you this information so you have a little bit of exposure to it. It's not something that we're going to focus on, but I do want to go ahead and give you some exposure. Those of you who move on to pre-cal, you will talk about domain and range quite a bit. For the domain, so all of the possible x values, so this line goes on forever in both directions in x, so we say that the domain is all real numbers. That like capital R with the 2 vertical bars means all real numbers, meaning all possible x values are part of the domain. And then the range, if you look at the y values, each of those points on that graph has the same y value. So the range or y values is equal to whatever that constant c is. This is one of the functions that you want to focus your attention on, that constant function. The next one is our basic linear function, and this is definitely another one that you want to focus your attention on. So the equation for the parent function is y equals x. You can see the graph of that here. You have a y-intercept of 0, a slope of 1. The graph of a linear function is a straight line where both the domain and range are all real numbers. So what you need to be focusing on is knowing the equation of the parent function and what the graph looks like. The next one that we are going to focus on is our quadratic. And characteristic of the quadratic is that it has that exponent of 2. So anytime you see an equation that has that exponent of 2, you know it has to be quadratic. If you look at the graph of this, the graph of a quadratic is a parabola. That's that U-shaped graph. The domain is all real numbers, but if you look at the y values, you don't see any y values below the x-axis. So all of our y values start at 0 or go up. So we say that the range is greater than or equal to 0. The next one is not one that we're going to focus on in our class. You'll see it a lot if you end up taking pre-cal. This is what we call the cubic function, and you see that exponent of 3 tells you it's a cubic. In pre-cal, we call this a chair shape. You can kind of see where, yeah, I know, I'm really good at drawing, where you could maybe see where that would be a chair. Domain and range here are all real numbers. The next one is the last one that we are going to focus on in our course, and that's the absolute value function. Easy way to spot this, if it has those absolute value bars, it has to be an absolute value function. The graph of an absolute value function is a V shape. A V shape. So if you see a graph that has the V shape, you know it's absolute value. If you see a graph that has a U shape, that's quadratic. Very similar to the domain and range of the quadratic, our domain is all real numbers. Our range is greater than or equal to 0. You see y values of 0 and going up. You do not see y values down here. So the next three, again, just giving you exposure. These are not ones that you're going to see a whole lot after today, but again, moving on, you will. So just some exposure so you know what these look like. Our square root function, so you can see the square root in there, has just one little bar right there. Both domain and range are greater than or equal to 0. Our exponential function, we will actually talk about exponentials later on this semester, but it's not one we'll focus on right now. This graph grows slowly, then very rapidly. So you see it's growing slowly, and then eventually it kind of goes almost vertically. Domain is all real numbers, range has to be greater than or equal to 0. And then finally, our last one, which is one that you'll probably have the least exposure to, is what we call the inverse function. So you see 1 over x. The graph has these two bars. Both domain and range are all real numbers except 0. So again, focus on the 4 that I highlighted for you. Know what the equations are of the parent functions. Know what the general graph looks like.